this video, we are going to explain the process of gas adsorption unit. Before that, what is gas adsorption? Scientifically, gas adsorption is an operation where the gas mixture gets contact with liquid to dissolve one or more component of gas mixture. From this process, we can observe a mass transfer from gas phase to liquid phase. Whereas, the reverse process of this is called stripping, where the volatile part of the liquid mixture is transferred to gas. In food industry, gas adsorption is applicable in the process of carbonation in beverages. Now, let us discuss in detail about the gas adsorption process by a related experiment. In gas adsorption experiment, we will operate vapor-liquid separation process using a packed column gas adsorption unit. From this, we can determine the percentage removal of CO2 in adsorption.
So now, in this experiment, there are two types of adsorption process take place, which is physical and chemical adsorption. The process depends on solute and solvent. In our experiment, we use water as our solvent. There are a few properties of solvent that need to be considered for the absorption to be more efficient. Properties of solvent such as gas solubility, volatility, corrosiveness, viscosity. However, for this experiment, we use aqueous sodium hydroxide as an adsorbent to dissolve our hydrochloric acid. Thus, the adsorptivity is accompanied by a rapid neutralization in liquid phase, which is the process referred to as chemical adsorption. So now, we already know about how the gas adsorption process. Let's take a look on how the experiment was done. Let's check it out!
In gas adsorption column, we have 4 parts, which is part A, B, C and D. In part A, we need to prepare the chemical required, while in part B is to operate vapor-liquid separation process using a packed column gas. In part A, we need to prepare 0.01 mole of hydrochloric standard solution and 0.01 mole of sodium hydroxide standard solution. To prepare the hydrochloric standard solution, we need to first pour 10 ml of HCl into beaker. Second, we need to pipette 10 ml of solution of hydrochloric acid into a volumetric flask. Third, add the ionized water up to mark level at volumetric flask. Next, shake the solution for a while. So, in order to prepare the sodium hydroxide standard solution, we need to firstly weigh 0.4 gram of sodium hydroxide pellet. Secondly, pour the 0.4 gram sodium hydroxide pellets into a beaker. Then, add the ionized water into the beaker. Next, we need to use the magnetic stirrer to dissolve the sodium hydroxide pellets into homogeneous solution. Then, pour the pellets of sodium hydroxide into a volumetric flask. After that, add the ionized water up to mark level at volumetric flask. Lastly, we need to shake the solution for a while. And we have already finished for part A.
Moving on to part B. In order to operate vapor-liquid separation process using a packed column gas, we need to set up the equipment properly using a table as a reference. After that, we move on to part C. Firstly, set the valve accordingly. Ensure that the water flow rate is allowed to stable for 10 minutes after each change until the desired value is reached. Then, set the air flow rate by gradually open the feed valve until the desired flow rate is about 40 liters per minute. Ensure that the water flow rate is allowed to stable for 10 more minutes until the desired value is reached. After steady state condition is reached, set CO2 flow rate by opening valve FCV2 gently until the CO2 rate is at 2 liters per minute. Allow it to run for 10 more minutes for the adsorption process to attain steady state. Draw 20 ml sample from the outlet valve for every 5 minutes. Repeat the experiment for 60 liters per minute air off flow rate. Thank you!
Now we have arrived in our last part of experiment, which is analyzing the sample. So we analyze our sample by using the direct titration method in order to get the amount of unreacted sodium hydroxide in our sample. We use the chemical that we have prepared in part A and also part C, and then we mix it so it will become a solution. So the solution, we titrate it and we drop a few of phenolphthalein in order to start our titration method. In the titration process, we have to make sure that we use a very good technique while titration the chemical fast. So what we have to do is we swirl discuss slowly and continuously. We stop the titration once we get the pale pink color of the solution. We have to be alert once we get the pale pink color. So after that, we will read the measurement at the burette meter. We have to make sure that our eye level with the level of the burette have to be perpendicular to get an accurate reading. So in the analyzing and discussion part, we have to do two things. First one is make a proper mass balance to calculate the percentage removal of CO2 from the absorption column, and the second one, we have to plot a graph of percentage removal of CO2 versus the time, and we discuss the effect of air flow rate on the percentage removal of CO2. So to undergo these two steps, we need to do a proper calculation. So let's have a look on the calculation.
In a nutshell, we have successfully absorbed gas through packed column in a batch process in absorption of CO2. It is observed that any changes in the flow rate of CO2 can affect this experiment. As the flow rate of CO2 increases, the absorption process also increases because the composition of the outlet volume of CO2 increases over time. However, there are few errors occur while we are running the experiment. Thus, it is recommended that before running this experiment, make sure to refer to the work instruction in order to fully understand the gas absorption unit. Next, collect the sample simultaneously from both inlet and outlet of the packed column. Other than that, ensure the titration process were done in a proper procedure. Lastly, avoid making any parallax error while taking the reading of the burette. So guys, I think that's the end of our video. Thank you for watching.